Hey, good afternoon. My name is Thomas Choi from SK hynix. I'm Director of DRAM Product Planning, and my specialty is memory standardization and pathfinding. Today, I'm going to talk about what efforts are being made and what efforts needs to continue to have the CXL memory development as robust as possible. So CXL brings great expectation to the whole industry because it brings exciting opportunities to enhance memory system values with so many emerging use cases. So all the industry players are teaming up to introduce the CXL memory product very soon, hopefully by next year or year after. Such value adds include memory expansion, tiering, pooling, persistent memory, near data processing, and memory as a service. So a lot of work ahead and many promises being made. I'm going to quickly touch on SK hynix's vision in CXL memory. So basically, I made some presentation in the Expo Hall talk yesterday, but to just summarize, we are all about overcoming current memory systems limitations to scale out of bandwidth and capacity. And with the new CXL memory coming up and with the new hierarchy being created, we aim to optimize the data efficiency and data center TCO. I would like to talk about some keywords for each value add that we think it's going to happen. First, in the bandwidth memory expansion, we assume that there's a 12 channel per CPU, like in the DDR5. And it's all about getting 13th through 16th extra memory channel with PCIe. We seek better interleaving, and we seek better loaded latency with the offloading to the CXL memory. About capacity memory expansion, the keywords that we keep thinking is about 2 DIMM per channel era near the end. And so we have to find some ways to allow capacity scaling better. And also we have to think about improving RAS and watts per gigabyte. And that could also happen with the expansion with tiering that could allow more cost effectiveness. Next value add is about memory media differentiation, where thankfully CXL is memory agnostic in nature. And that means we can pursue standardized DRAM as well as the custom memory media for various use cases and explore multiple design trade-offs for various end user needs. For the memory media control differentiation, keywords include, well, it's beyond common IPs, making differentiation features that can improve better RAS, security, lower power, and perhaps more addition of computational features. Lastly, it's about memory as a service, where through tiering and pooling, you can choose different kind of memory types for building pooling appliances and creating composable architecture. Now, I would like to talk about memory requirements and the newly features for CXL memory in order for us to understand what the tasks are to develop a good CXL memory. So traditionally, memory requirements for local DDR memory has been all about scaling up the bandwidth and capacity together while keeping power and cost at the same level. That has been the same for the last 20 years. CXL memory requirement will be slightly different. So let's look at what the DDR is happening. So starting at DDR3 to 4 to 5, you're looking at bandwidth doubling up per generation, capacity doubling up per generation. However, the DRAM scaling limit is asking for some decrease in the ratio, the slope of the increase in the die capacity. Therefore, we are looking at 96 gigabyte first, and then 128 gigabyte, compared to DDR4 64 gigabyte. So this is the traditional way of thinking the memory requirements. For CXL memory, it's slightly different because it's going to have a longer latency due to the controller attached to the CXL memory module. And the interface, the PCIe itself, has to have a longer latency. And then, due to the different use cases such as tiering, there has to be a variable sweet spot for bandwidth and capacities. So, when you look at DDR, you can think of, for example, in latency, around 100 nanoseconds from CPU to turnaround. For CXL, idle latency might be around 150 nanoseconds. So, bandwidth-wise, strict requirement might be more like memory class bandwidth. It's not going to specify what exactly will be the number. But eventually, for the capacity scaling, due to that problem of 2 DIMM per channel era near the end, we're going to have to create larger capacity than DDR. So these are the basic requirements, I believe, it is for the CXL. Now to the features. For the newly introduced memory features for CXL, we have to think about migration of some memory controller features into CXL controller, because all the host functions that is needed for DRAM scheduling needs to migrate into CXL controller somewhat, because DRAM is behind the CXL controller, not like host directly attached to the DRAM media. And also, so those examples include like enhanced RAS features and ECC embedded in the memory controller these days, security features which are to be consistent with the host enhancements in the security features, low power features, firmware management related features, and computational and accelerator features that could be embedded into CXL controller. So there are some of the candidates that could be embedded into CXL controller. And also there could be some vendor-specific or vendor-optimized features in the CXL controller. Next category will be about CXL memory media-specific features, like custom features to optimize for different design trade-offs in power, cost, capacity, and bandwidth. And also there might be some variations in specific features from the current JEDEC standards. And also we should not forget about some specifics related to module mechanicals. What I'm talking about is we are integrating all components, including the CXL controller, with the DRAM, and that has never been happened in the history. So what we think of in the DDR5 modules, how the components are placed, how the PMICs are, might be different from what the CXL placement might be for the CXL memory module. Therefore, there are some newly features that we have to consider. So with these new requirements, slightly new requirements, and some new features, will the development of CXL memory be easy, natural? Absolutely not. So this is going to be a challenge in enabling CXL memory about how to meet the CXL memory requirements and how to evaluate and validate this new concept or new memory CXL memory module features. And development process itself may be new to the industry. Although we have some existing literatures, this particular way needs some good thoughts on how to make this whole process robust. So about meeting requirements for the challenge points include achieving reasonable bandwidth amid longer latency from CXL. So there are certain pin speed that we have in DDR5, for example, but since we have longer latency, that bandwidth is going to be compromised from the same memory media. So we have to find some way to make some enhancements. For the capacity, it's all about doubling or more the capacity versus DDR5, but with TCO awareness, meaning if it's too expensive, like claimed in 3DS with TSP, that's not good news or not a good way to pursue this. So we have to find some ways to make this high capacity memory more cost effective. We have to maintain power amid more components that are being included in the CXL memory module. Controller power is not going to be lower than that of the current very small components like RCDs and data buffers. So this will be a challenge. And also, we have to put more features for the better RAS and security, but we cannot really put more cost on that. So these are all the challenges for the meeting requirements. For the evaluation and validation, it's all about offloading traditional host-related features to CXL controller. So this is maybe foreign to many device vendors, controller vendors. So that needs more work. You have to be consistent in terms of RAS level and security level compared to those in local memory. We have to get used to the environment, so that also needs some time and more work. And also, some may debate about who is responsible for each validation item. So I'm going to talk about more about that in the later slide. So understanding the requirement challenges and how to enable these features, which might be difficult at the very first time. I'm going to talk about all the efforts that are being made and should be made to overcome those challenges. First is about planning bandwidth scaling with performance evaluations. So the ultimate to-be goal will be understanding bandwidth and latency trade-off in CXL and find performance enablers to allow bandwidth scaling. Current findings suggest, as shown in the graph in the below in the left, we see some promising results, like up to 50% improvement in memory throughput with MLC workload with 2 read, 1 write condition, or around 20% improvement in execution time with spec workloads. But we see that, especially in the latency, there's some room for improvement from various areas, including the module itself and the CPU with the CXL enabling. Another point that I would like to highlight is about utilizing software accompaniments to achieve better performance, especially in the bandwidth. So HM SDK, heterogeneous memory SDK provided from SK hynix, seeks to further enhance the bandwidth with bandwidth-aware interleaving between the local DDR5 memory and CXL memory. So that will be just one example. And we were all talking about how software-defined memory could help the CXL use cases. So I think not just about the features, but philosophy, like SDM, might be very influential factor in enabling this CXL memory in terms of the bandwidth scaling. Next is about capacity scaling, building concepts. So I believe the #1 factor in pursuing CXL memory is about capacity expansion, preparing for the 1 DIMM per channel era. So I know Micron has explained some about the trend. So back in DDR3 and early DDR4, it was 3 DIMM per channel era. So up to DDR4 2133, you've seen some 3 DIMMs per channel, but not anymore. You see only 2 DIMMs per channel these days, starting with the DDR4 2400 to now. And maybe that 2 DIMM per channel era could continue till DDR5 5600-ish. So perhaps with 6400 megabps and above, that's where we have to think about 1 DIMM per channel. So DDR5 later era, and also DDR6 coming up in late 20s, it's going to be 1 DIMM per channel. Meaning, for the capacity scaling, just relying on DDR may not work. Therefore, we have to think about capacity scaling using CXL memory with the high capacity memory. So we have to find enablers for this capacity scaling with cost effectiveness. So either we have to think about die density scaling with a larger die in an SDP, single die packages for the capacity scaling. But it has been very difficult for the die density scaling due to the tech node limits. So I think more important part will be about how to find more cost-effective stacking. And one more thing to keep in mind is that just focusing on capacity scaling is not the whole picture. is heard in various industry major players. Also, we have to think about bandwidth to gigabyte ratio. That must be consistent. Next is about how to landscape this memory enabling process. I think I may need to change. Okay. All right. So what I want to talk about in this particular slide is about how important it is for us to think about integrating this enabling process from multiple literatures. We were very comfortable with memory enabling with like DDR, with DIMMs, with the CPU being the center of the whole process. And then there's a PCIe with SSD where it's not that centralized like in DDR with DIMMs. But CXL is about memory, but with PCIe infrastructure. So we have to think about how to integrate these multiple literatures well. And also we have to think about how to utilize this standardization of CXL memory. In order to create more volumes for CXL memory, I strongly believe that some level of standardization needs to be firmly complete. So it's about standardization. Some may think of in the JEDEC ways. Some may think of the more the PCI SIG, NVMe Express ways. So we have to find the best optimized ways to standardize CXL memory without stifling innovations. So there are many MOUs being planned between multiple standard bodies. And a good example will be recent announcement of MOU between CXL Consortium and JEDEC. So we are looking forward to more works for the standardization of CXL memory. So at the end, there are so many features or so many categories that we need to consider shown in there. It could be interface protocol, system features, memory features, including DRAMs, the media exclusive features, form factors, connectors, management, mechanicals, and all of that. We have to answer the question that I highlighted. Who validates what? How and whether to standardize, and what existing literatures can be leveraged. So for each category, we have to carefully consider how to answer these questions the best way. Next is about exploring sweet spot application use cases. So there are many good presentations about how to improve data efficiency by selectively offloading cold access to second tier. So since there are many rooms for improvements, there are some over provisions of memory. So there were some various good offerings in research about building prediction model, changes to swap and compression engine, kernel modification in allocation, changes to some NUMA policies with optimized page table migrations, fabric manager models, and so on. So right now, our observation from looking at all the good research papers from major industry players is that definitely there is some improved data efficiency, but performance drop has to be contained with good learned management in page table and events and so on. So I believe that understanding behaviors OS, control plane, QoS will be very critical to find more optimized data distributions. And I expect that more research are to be followed on the tiered memory performance analysis, and also perhaps more studies on the RAS and security next. Last thing I want to highlight is about creating more POC evaluation opportunities. Alongside research, we have to keep knocking the door with several POC developments. If we don't do that, we don't have any particular number for the CXL market without such industry collaborations. So I think those POCs definitely begins with CXL memory expanders, and some may offer prototypes of computational memory solutions like SK hynix. And maybe in the more future, you will be able to see some pooling appliance POC with the whole industry partners. And on the picture, this is SK hynix's 96 gigabyte E3.S POC sample with ASIC controller from third party. This was announced in August 1st, and we are running live demos of this E3 sample. I think the demo booth has ended by now, but I'll be more than happy to share those results offline. So for a POC like this, SK hynix aims to be more friendly to customers with adding options in the POC sample to support legacy options, such as attaching PCI connectors to this E3.S in order for customers to evaluate this with the platform that still needs work on the backplane and only can use the PCIe existing platform infrastructure. Also, like in AHM SDK, we plan to accompany some software tools and guidelines to run the POC more smoothly. So the conclusion is that definitely CXL shows a lot of promise, and with many value-added use cases. However, CXL introduced a new paradigm, and this new paradigm sounds excellent, but also it brings more challenges to all of us, because it's basically uncharted territory in executing the actual process of CXL memory development. And with these new requirements, features, we have to think about how to validate this well. So SK hynix is working very hard to achieve bandwidth and capacity scaling of CXL memory by going through extensive performance analysis. And we are going through very heavy concept engineering to create ultra-high capacity memory solution with cost effectiveness. And industry-wise, there are already many researches going on to find optimal use cases for CXL, and that will continue. And SK hynix is looking forward to contribute more to the industry by creating more POC opportunities worldwide. So I'm very looking forward to close collaboration with all ecosystem partners to build value-added CXL memory products. Thank you.